So let's just jump right in. For a long time now, AI's been this pretty helpful sidekick for coders, right? Like a super smart autocomplete. The folks behind GLM-5 have a great name for it, vibe coding. But what if we could blow past that? What if an AI wasn't just an assistant, but could actually be an autonomous engineer? Well, that's the whole ballgame for GLM-5. It's built to make that exact leap.
I mean, the AI world is just jam-packed with heavyweights, right? All fighting for that top spot. So whenever a new open weight model throws its hat in the ring, you gotta ask, is this one for real? Is it a true contender?
Oh, yes. The answer is a huge, resounding yes. I mean, right out of the gate, GLM-5 didn't just do well, it shot straight to the #1 spot for open weight models in the Al Moreno code rankings. And just to be clear, open weight means its brain, its core intelligence, is out there for anyone to use and innovate on. Now, this isn't some lab code synthetic benchmark. No, this is a real-world arena, a head-to-head fight judged by actual people. And you've got to look at this list. It's not just the best open model. It's right up there, going toe-to-toe with the biggest, most powerful closed-source models in the world.
Okay, so that's one heck of a first impression. But to really get what's going on here, we have to look at the whole picture, its performance across what they call ARC, agentic, reasoning, and coding tasks. Because believe me, this thing is no one-trick pony.
All right, now this is where it gets really wild. Look at this. On the left, you've got the text arena. That's for general language stuff, creative tasks. On the right, the code arena for pure programming. And GLM-5, it's #1 in both. Just let that sink in for a second. To be the top dog in both of these is, well, it's incredibly rare. We're talking about a model that can write you a poem and then turn around and architect a complex piece of software. That's some serious range. But wait, it gets better. Its skills go way beyond just spitting out words and code. See, real intelligence isn't just about one-off answers. It's about playing the long game. It's about strategy. And that's exactly what this chart is all about. It comes from this really cool benchmark called Vending Bench 2. Here's the deal. The AI has to run a simulated vending machine business for a whole year. It's not about one right answer. It's about thousands of tiny decisions, managing money, stocking up, real long-term planning. And that bright pink line just climbing and climbing? Yep, that's our model, GLM-5. So after a full year in the simulation, what was the bottom line? $4,432. That number right there makes it the best performing open model on a task that requires serious long-range planning. So the key takeaway here is huge. It's not just following instructions. It is strategizing.
Okay, so let's tie this all together. Check out the Artificial Analysis Intelligence Index. Its older sibling, GLM 4.7, had a solid score of 42. GLM 5, it jumps all the way to 50. Now that's not just a big jump, that is a massive leap. It makes it the very first open weight model to ever break the 50-point barrier on this index. It's the new undisputed leader of the pack.
So we've seen what this thing can do, and it's impressive. But the billion-dollar question is, how? What's actually going on under the hood that makes this kind of performance possible? Let's take a look.
Okay, so the first big piece of the puzzle is its architecture. It's called a mixture of experts model, or MOE for short. And the best way to think about it is like this. Imagine you have a board of directors, but each director is a world-class expert in one specific thing: finance, marketing, engineering, whatever. Now, when a finance question comes up, you're not going to pull everyone into a meeting, right? You just grab your finance expert. That's exactly how MOE works. It only fires up the specific expert networks it needs for a task, which makes it super powerful, but also incredibly efficient. And this table really shows you just how massive this upgrade is. The total parameters, think of that as the model's entire library of knowledge, more than doubled to a crazy 744 billion. The number of those experts we just talked about, that jumped from 160 to 256. But here's the magic trick, the secret sauce of the MOE design. Look at the activated parameters. That's how many experts are working on any one problem. It barely went up. So you get this gargantuan leap in power without the insane computational cost you'd expect. It's the definition of working smarter, not just bigger.
But you might be wondering, how on earth do you manage a model that huge and still keep it running efficiently, especially when you're feeding it tons and tons of data? Well, that leads us to its real secret weapon. It's a brand new innovation in the architecture called DeepSeek Sparse Attention, or DSA. So your typical AI model, when it reads a long document, it has to look at every single Word. And that gets really, really expensive, computationally speaking. DSA is a total game changer. The best way to think of it is like AI speed reading. It scans the whole thing, and as the paper puts it, it looks at the content to decide which tokens are important. It just zeroes in on the stuff that actually matters and ignores the rest. This lets GLM-5 process these huge amounts of information without breaking a sweat. Or the bank.
In this whole process, all these different parts, they get forged together in this really sophisticated multi-stage training pipeline. It's like a 3-act play. Act 1, on the left, is this giant pre-training phase where it just absorbs a universe of general text and code. Then, Act 2, in the middle, is this critical mid-training stage where it starts specializing in long documents and agent-like tasks. And for the finale, on the right, it gets fine-tuned with reinforcement learning to really sharpen those reasoning and agent skills. Each step builds on the one before it, all to create this brand new kind of AI.
And all this tech, it brings us to what might be the most important point of all. We are moving past the idea of a simple coding assistant and stepping into something totally new, the dawn of the autonomous agent.
So GLM-5 has these new ways of working that are key to this whole agentic shift. First up is interleaved thinking. This just means the model actually stops to think before it responds or uses a tool. It plans its move. Then there's preserved thinking, which is huge. It means the model can actually remember its train of thought over a long, multi-step conversation. It doesn't forget what it was doing. It builds on its own ideas, exactly like a human engineer working through a complex problem.
Okay, but this brings up a really fascinating and honestly a really tough question. If you have an AI that can just go off and build a complex piece of software all by itself, how in the world do you test its work? I mean, your old school code test just can't handle something that's interactive and visual. Well, the solution they came up with is just as clever as the AI itself. You get another AI to be the quality assurance tester. They call it the agent as a judge pipeline. And let me tell you, this is way more than just a neat little trick for grading the model's homework. This is a massive step toward a future where AIs can build, test, and approve each other's work all on their own.
And we're not talking about a simple spell check for code. No way. This judge agent acts just like a person would. First, it reads the source code. Then it actually boots up the application. It starts clicking around the user interface, taking screenshots as it goes, and checking everything against the original requirements. It can catch all sorts of bugs and visual errors that a normal code test would be blind to. And at the end, it gives a final verdict: pass or fail.
This right here, this is exactly what the creators are talking about when they say, and I'm pulling this straight from their paper's conclusion, that this is the start of a new era where AI agents autonomously plan, implement, and iterate on complex tasks. So let's be clear, this isn't just about a slightly better tool. This is about a fundamental shift in how we approach building software, period. So when you put it all together, the advanced reasoning, the long-term planning, and this incredible ability to test its own work, you have to ask yourself, is this it? Is GLM-5 giving us the first real look at the future? Are we watching right now as AI makes the jump from coding assistant to autonomous engineer?